Hello, welcome back to this mini-series on quadratic equations. So in episode 4 we're going to look at factorising. So as we've seen in our previous videos, that factorising is a common tool used for solving quadratic equations, i.e. finding the value of x. So first of all we should also say what factorising it is. So a factor of a number is any numbers or whole numbers that can be multiplied together to make that number. So for instance, if we take the number 6, the factors of 6 are 1, 2, 3 and 6, because we can do 1 times 6 to get 6, or we can do 2 times 3 to get 6. So it's this idea of being able to multiply whole numbers together to make another number, and those numbers that you multiplied are the factors of that number. So when we apply this to quadratics, it means we put things into brackets. So I've got 4 examples we're going to work through here. So this first one here is called a monic quadratic, which means that the a coefficient, the number in front of the a squared, is just 1. So I'm going to go over a technique which just allows us to factorise reasonably easily. Bear in mind that not all quadratic equations are factorisable. So if we start off, first of all, we need the 2 brackets. If it's monic, we put an x in the beginning of each bracket. So what I learned in school was you look at the first sign in the quadratic, or the sign in front of the b coefficient, and we put it in the second bracket. So in this case, it's a positive. We then look at the second sign in the quadratic, which in this case is a negative, and if it's a negative, it means that we look at the sign in the second bracket and it's going to be different to that sign. So different to positive is going to be negative, so we're going to put a negative there. If this was a positive, we would have to put a plus here. And the reason for this is this 14 is actually minus 14, and we need 2 numbers to multiply to make minus 14. And the only way to make a negative number by multiplying is to multiply a negative by a positive, hence why we need a negative and a positive in these brackets. We now need to, well, throughout all of these ideas of factorising, we need to have a good basic understanding of numbers. And what I mean by an understanding of numbers is we are now looking for 2 numbers that when multiplied together make 14, and when taken away make 5. So let's look at the 14. So we can have 1 and 14. So 14 minus 1 is 13, that's not 5. We can have 2 and 7. So 7 minus 2 is equal to 5. So those are the 2 numbers we have. And with this way of arranging the brackets, we can put the lowest number in the first one, which will be 2, and the second number in the second bracket, which is 7. So this is this quadratic equation of x squared plus 5 plus 5x minus 14, when factorised, will form 2 brackets of x minus 2 and x plus 7. So that's our first example. So this is number 1. Number 2, we have x squared plus 6x. So if you notice, we've got no c constant at the end. So in this one, we actually only need to do 1 bracket, because in the first bracket, which we haven't written here, one of the terms is going to be equal to 0, because again we need to look at numbers that would multiply together to make the c constant, and since our c constant is effectively just 0, one of those numbers is going to be 0. So for this, we can now just take out any common factors, and you can see both these terms have an x involved, so that's going to come out and go outside the bracket, and then we just make up the bracket of what we need what else we need. So we have an x squared term, so we need something to multiply by x to make it x squared, which is x. The plus stays where it is, and now we need a number which when multiplied by x becomes 6x, which is just 6. So this is number 2 factorised, so solutions for this would either be x equals 0 or x is equal to minus 6. We're now going to have a look at number 3, which this is not a monic quadratic because we have a 9 in front of the x squared, and this time we have no x term and therefore no b coefficient. And the tip I'm going to show you for using this is, if you can just write this, put a plus or minus 0x in and try and solve it that way, or for these ones, and I've picked this example specifically because both 9 and 36 are squared numbers. So if you see it in this form, we can open both brackets again. We're looking, put the x's in. Because 9 is a squared number, we can put the square root of 9 in, which can be 3. We're going to need a minus and a plus, and it doesn't matter which order I put this in. And then we need two numbers which multiply together to make 36. And again, because that's a square number, it can be both 6. So if we expanded this out, we get the 9x squared and the minus 36. But also you'll notice you'll end up with minus 6 times 3x, which is minus 18, plus another 18x, which is 0. So that's where that middle term has gone. So finally, we're going to go on to this fourth question, which has an a coefficient of 6, a b coefficient of 5, and a constant of 6. So this one's a little bit trickier to do. We're still going to end up with two brackets, but there are numerous methods to do this, but the method I'm going to use is this. First of all, I'm going to multiply the first number by the second number. So I'm going to take these two, the a coefficient by the c coefficient. So I'm going to do a times by c, which is going to be equal to minus 36. What I'm going to do now is look for two numbers that when multiplied make minus 36. And because of this take away sign, take away to make 5. So factors of 36 are 6 and 6. So that's no good because when we take those away from each other, we're not going to get 5, we're going to get 0. We could look at 3 and 12. Again, taking 3 away from 12 isn't going to help because we're going to end up with 9. We could end up with 9 and 4. So we have minus 4 plus 9, and that would give you this 5x. So the next stage then is to rewrite this, but with this 5x term replaced with the minus 4 plus 9. So we have 6x squared minus 4x plus 9x minus 6. The stage we get to now is we split this into two boxes. So we take this as the first block, including the first two terms, and we make the second box the second second set of terms, and we factorise each of these boxes. So if you notice, this first box here looks very similar to example 2 we did before. So we can see that there is a common factor of 2 in this. So 2 goes into both 6 and 4. So if we start off by writing that, also x is a common factor on these terms. And then we can open the bracket. To make 2x into 6x squared, we need a 3 and an x. We have the minus sign, and then to make 2x, 4x, we're going to need a 2. And then we add that on to the factorisation of this next one. We see we got a 9x and a 6. And again, these are going to become there's going to be a common factor that come out here of 3. and then in brackets we're going to have a minus in this bracket we're going to have an x and a 2 times 3 is 2, so we have in brackets minus x minus 2. So if you can see now, we have two brackets which are the same, or could be the same. They both have an x in it. Oh, sorry, there should be a 3x here, so that should be another 3 there. There we go. So we should have 3x minus 2 in both brackets. So this is going to be one of the factors, so we can write that down. So we have 3x minus 2. And then to form the other bracket, we just take the outside parts. So we take the 2x plus 3. And now we've factorised this non-monic quadratic equation. So this, as I said, there's lots of different methods for finding factors of these style of quadratic equations, but in this one we multiply the a coefficient by the c constant. We look for two numbers which, when added together or subtracted from each other, make the middle b coefficient, and when multiplied make that number by multiplying a and c together. We rewrite the quadratic expanded with those new numbers in. We then basically refactorise each of the first two terms and the third and fourth term into two more brackets with a number outside them, and then we keep the bracket the same and form the second bracket out of the two other coefficients. So in our final episode we will look at solving quadratic equations by completing the square.